In this video, I'm just going to take a quick look at the scatter plots if we want to plot two continuous variables together. So often we're looking for associations or trends or relationships. If you've just got observational data, you really can't make any statements about cause and effect, but you certainly can look for interesting patterns in the data. As regards height and weight, obviously we would expect people to get a little bit heavier as they get taller. Oh, I've plotted this backwards. There we go. I'll do that again. But this is what we're aiming for, a scatter plot. So under Graphs, Chart Builder, and I'll reset that. In the scatter dot option, we've got a few things here and they're all very useful. We're going to take a look at the first one. Now when I said I had it plotted backwards, it's just a matter of tradition really that we usually put the variable which we think comes first in a manner of speaking along the x-axis. If this was experimental data and we were trying to show cause and effect, we would put the cause on the x-axis and the effect on the y-axis. In this case, I'm plotting height and weight, and because usually people have a height that they're going to grow to and the weight is somewhat dependent on that height, we would put the height first on the x-axis and then the weight up the y-axis. But if there's a relationship, you'll see it either way, so it's not terribly important. And here we can see that as people get taller, they get a little bit heavier. But it's not a perfect relationship. Obviously, there's lots of other things that affect your weight besides your height. And if this was genuine data from a real population, I don't know how strong the relationship would be. The weights are a little bit on the light side. There's a couple of problems with the simulation. Now, you can stop there, but there's a couple of other things that we can do with this graph. The first thing is that we could actually split this by a third variable if we wanted to, and this is a really handy thing to do if you've got complicated relationships. So if we were interested in height and weight, we would probably want to split that by gender, just because we know that there are some differences in height between males and females, because males are on average just a little bit taller. So if we go into Chart Builder and we choose the next option here, we can choose to colour these dots by a third variable. Now this third variable needs to be categorical, and it's easiest to read if there aren't too many levels involved. So gender is nice, but if you've got some kind of variable that's got 10 different levels, unless they're really, really distinct, you'll find it just creates a bit of a mess. So I'm going to put gender in there. And we've got the males in green, and they are a little bit taller, so they're offset slightly from the women. Now we do have these two outliers here, and these are going to make the relationship look a little bit stronger than it otherwise would. So the other thing you can do with scatterplot is put what we call a fit line in, what would be the line of best fit. I'll go back to the simple one. If you do this in Excel, it will print out the correlation for you, I believe. If you do it in SPSS, it actually gives you the regression equation. So you don't need to worry about that at this point. You can actually just, you might be able to select it and delete it if you want. No, I can't delete it. I'll just ignore it. Now, by default, it'll just try and fit a straight line to it, which may or may not be appropriate. Depending on how advanced you're feeling, you might prefer to try and put a curved line of best fit through the data. And in this case, that actually looks like it fits a bit better, but I would guess that's just because we've got these outliers here. And probably wouldn't want to run this without a lot more data. But you can put those fit lines in. If you've got the variable split by a third, it should allow you to add a separate line for each group. So add fit line at subgroups means add a separate line for each of the groups we're looking at, so the males and females separately. And you can see that it gives you an idea of how much effect these outliers are having on the data, because you can see that the green line has been pulled right up. That's a really steep slope. whereas the line for the females, there is a relationship there, but it's a lot shallower. So that's the adding the fit lines. If you want to get the correlation out, I'm not sure if SPSS will put it on the graphs, you can go through the Analyze menu and correlate and look for your bivariate correlations. And that would be height and weight. That'll just be everyone together. We could do some more advanced stuff and split our file by groups, but we won't do that in this video. So the correlation here between height and weight is 0.631, which is pretty strong and it's significant. If you took out those outliers and did it again, I think that would drop a fair bit.